So now that we know these derivatives of sine and cosine, let's put them into action. And I will say, just for starters, that part of pre-calculus, you learned about the trig functions, and you had the trig common value chart that you were responsible for. That's going to come back here as well. You're going to need to know the values of sine, cosine, and tangent for x equals 0, x equals pi over 6, pi over 4, pi over 3, pi over 2, and pi, and the other ones as well. But those are the common values you want to have ready to go. So not only do you need to know your trig derivatives, but you need to know your trig common value chart and be able to pull it up on a moment's notice. So let's go ahead and do that. We've got example 14. You see there on the paper in front of you, f of x is equal to the sine of x, and we are interested in f prime evaluated at pi. Okay, so before we can get f prime of pi, we need f prime of x. So to get f prime of x, we need the derivative of the sine of x, and the derivative of sine of x is cosine x. All right, so we know that right there. We're interested in f prime of pi, so we're now going to plug pi into our derivative. So our final answer, f prime of pi, will be the cosine of pi, and we need to know what the cosine of pi is equal to. So you refer to your common value chart from last year. I can also I'll have one up on the website for you to print out if you'd like to have it handy. But you do want to know these values. The cosine of pi is -1. So our final answer is that f prime of pi is equal to -1. Okay. Just beneath that, you see example number 15. Example number 15, we're given that f of x is equal to the cosine of x, and we want to write the equation of the tangent line at the point where x is equal to pi over 3. So we know from previous lessons that when we're trying to write an equation, we want to use point-slope form. All right, so hopefully you remember point-slope form. Y minus y1 equals m times x minus x1. Okay, that's our point-slope form. And we have to plug in for x1, y1, and m. Okay, now the x1, most of the time, is given to you. And that's the case here as well. The x1 value is pi over 3. So we can put pi over 3 in for x1. What we still need are y1 and m. Whenever you want the y value of a function, you just plug the x value into the original function. So y1 will be equal to the function's value at pi over 3. So that means we need the cosine of pi over 3. So again, we go to our common value chart. And the cosine of pi over 3, you can see, is equal to 1/2. So y1 is 1/2, and we can have y minus 1/2 right there. Now we need the slope. We need the slope of the tangent to the curve at a point. We know that that is the derivative. So in order to get our slope here, we have to get our derivative function, and we have to plug the x1 value, pi over 3, into that derivative. So let's get f prime down here at the bottom, f prime of x. The derivative of cosine, starting to work with that, is the opposite of the sine of x. Okay. Now we're interested in the derivative's value at our given x value, which is pi over 3. So we want f prime of pi over 3, which is the opposite of the sine of pi over 3. Okay. Sine of pi over 3 from our trig chart we see is radical 3 over 2, but it's the opposite of that. So we'll have negative radical 3 over 2. That is our slope. That goes right here. And we have written our equation. Again, we don't need to put this into slope-intercept form. We just need to write an equation of a line. That is the equation of a line.